Welcome to this video. We're going to be talking about how to find the composition of a function. And so hopefully by the time you get done with this, or we get done with the lesson in class, you will be able to find the composition of a function, and then also that you're going to be able to use that composition to determine if two functions are inverses of each other. And then we're also going to be able to use synthetic substitution to find the composition value. And then we're also going to find the domain and range. So those are the things that we're going to look at. So real quickly, the words that we're going to talk about is composition, and then we'll go into talking about inverses, and then the domain and range. So those are all things we're going to talk about. So an example of where you might see the composition of a function in real life is anytime that you're doing something where you take one value and have to use it for another value. So a very good example is your paycheck. So you have to take the number of hours and multiply it by how much you get paid per hour, but then you also have to multiply it by your tax rate. So it's not just taking your number of hours to one step, you actually have to take that answer and do another step to it. Okay, so that's what we're talking about in terms of a composition. It's more when you do more than one step to a number on there. The example they give you here is take the value from line 31, multiply it by 0.03, and then subtract 10,500 from this value, write down that amount. So that would be like on your income tax, okay? And that may not make sense, but hopefully we'll give you some more examples that will make a little bit more sense. But basically, it's a two-step process in what you're doing here, okay? Also think as composition, another word for it the kids like to use is substitution. So if you think about how you do a substitution problem, really that's all you're doing here, okay? So our notation that we're going to have, okay, is this notation right here, okay? And you could see it in either way, okay? So the first one is just using the parentheses, and what that means is substitute g of x into f of x. So we're going to take whatever our g of x equation is, and we're actually going to put that into our f of x equation. That is the same thing that the open circle. Now don't confuse that with the multiplication symbol, which is a closed symbol, but this means the same thing. So we're going to take g of x and substitute it in for into the f. So they both mean exactly the same thing. Two ways of writing the same problem. And so you'll see me go back and forth from one to the other, okay? So we're just going to go ahead and jump right in and look at some problems on there. So if you'll look at this first one here, you are given that, let's see if I can make this just a little bit bigger for you. You're given that f of x equals a negative 4x minus 4, and g of x is x squared plus x plus 5. And again, what this says is take g of x and put it into f. Okay, take g and put it into f. And so one of the things that I'd like to do, and I think it's a good plan, again, I'm going to just go ahead and make this a little bit bigger for you, okay, is we're going to take this, let me see if I can make that not quite as fat. That's kind of big. Okay, let me erase it. Okay, we're going to take this here, okay, and we're going to put it right there. Okay, so if you have a highlighter, I really think that is a good thing to do, is to highlight what you're going to do. So we're going to write this out. F of g of x equals, and again, negative 4, and we're going to take the other and put it right here. X squared plus x plus 5 minus 4. Okay, do you see what we did? We just substituted that whole equation. So instead of substituting just a number, we're substituting the whole equation. So what would I do next? Well, I would go ahead and distribute, which this is now the easy part, and simplify. Okay, and then you're done. So f of g of x would equal a negative 4x squared minus 4x minus 24. Okay, now I'm going to go on down to the next step, just right below here, and it says, okay, now that you have done f of g of x, we're now want you to do f of g of 2, which is saying take your problem, and we're now going to put a 2 for the x. Just like what we did when we were doing our other functions where we had to put numbers in. Okay? And again, if you look at this, guys, don't make this overly difficult. See how this is the x right here? And this is in the same position. And so that means that I am going to put for this x a 2, which is what I did. Okay? From there, it's just going to be a simplification. And you can run it in your calculators however you want to do it. Let's see, 4 times 2 is 8. We'll go ahead and do that one. And negative 16 minus 8 minus 24. What is that today? 48 negative. Check my math on there. So f of g of 2 would be a negative 48. That's how you would write that. Okay. Again, that would be your final answer up there. This would be your final answer here. I'm going to box it. Okay. Okay. And then the last one. Now this one's going to be a little bit different because if you look where the 2 is at, it's no longer where the x is, but it's telling you what it equals. Okay. So it's saying take f of g of x and make it equal to 2. So that means I'm going to go back up here to my f of g of x, and I'm going to take that negative 4x squared minus 4x minus 22 or 24, and I'm going to set it equal to 2. Okay, because now it's telling me what it's equal to. So again, I'm going to move this over. So I'm going to get a negative 26. Okay, and we could take out a common factor and see if it would factor. So let's take out a negative 4. That's going to give me an x squared. I'm taking out a negative, so that becomes plus x. That's not going to work because 4 won't go into 26. So we didn't even need to do that. Okay, so this would be your final answer. Okay, that's all you could do. So when it's over here and it says it's equal to, then that is what we're going to set our equation equal to. So those are the 3 things you're going to see. Okay, let's try another one. Now this time I put it in terms of with the open composite, but still it's saying we're going to take this and put it into that one. Okay, so when I look at my problem, again, I'm going to take G and put it into F. So again, I can't express enough to you. I would highlight that. When I say I'm going to take G and put it into F, I highlight G and then I highlight my X on my F. So F composite G of X is the absolute value of 3x minus 1 plus 2. Okay. Now, this is not an equation, guys. You're just doing a substitution, and now I just need to simplify. And I'm done. Again, this is just notation over here on this side. Okay, it's telling you that what you're doing, this is like the rule. Let's just put that there. This over here is the rule. Okay, so you're not ever going to do anything with it. Okay, so you don't touch that at all. Okay, let's go on down. Now it says do F composite G of 2. So again, I'm going to take what I just did and I'm going to put a 2 there. So I have 6 plus 1 is 7. Okay, we got that. I guess I could do an extra step there. So F composite G of 2 is 7. Now, if we were graphing that, that would be a point that was given on that absolute value curve. Okay? And our last one. Again, this time now, whoops, this time it is in the equal position. Okay? So we're going to take our equation and set it equal to 4. Okay? Because now it's saying that function we found, which is this, is now equal to 4. So now we have this absolute value equations. That takes us all the way back, guys, to, gosh, I don't know, was that chapter 2 or so? So we're going to set us up an absolute value. Remember, absolute value, I think I forgot to put an extra bar there. There we go. Absolute value equals the positive or negative. So we're going to have us 2 equations to solve. Okay, and then same thing on the other side. Okay, and then that would be our answers here. Okay. Okay, how hard is that? Spread it back out. Okay, so again in class, next period, we will do some of these together, but that just hopefully gives you just a little bit more of an introduction as to what we're doing on here for the next lesson.